All right, so just when you thought you were done with the stoichiometry, we have just a little bit left to do, not much. So we need to talk about gas stoichiometry and STP. And what do you think STP stands for?
Well, I know.
Well, we've talked about T's and P's.
So
Any guesses?
we got some temperature and we got some pressure.
Okay, so standard temperature and pressure is what STP stands for. And when they tell you that something's at STP, it's telling you that the standard temperature is 273 Kelvin and your pressure is 1 atmosphere. So anytime you see that something's at STP, that should be a dead giveaway of, hey, it's 273 Kelvin and 1 atmosphere. And they don't have to tell you that. They're just going to say at STP, and they're expected for you to know it.
Yep. And this would be the same thing as 0 degrees Celsius that you would then, add 273 to change to kelvins. And obviously your corresponding atmospheres would be.
All right, so if we have an ideal gas that is at STP, its volume will be 22.4 liters.
Yay!
Again, something you're just kind of expected to know.
You kind of have to remember it, although it is in your chart.
Yes, it is on your reference pages. All right, so let's do some calculations. Our first question is, what is the volume of 1 mole of gas at STP?
So if we
Start with,
I have a pressure, right? Because I got my STP, right? They said it was 1 atm. I've got my temperature, because there's my T, and it's 273. 7. Okay. Okay. I know I have 1 mole, which is an N. And I'm looking for a volume. So that looks like the PV equals an RT formula.
it does, but we're going to show you how to set it up using stoichiometry instead, because you can do it a little bit simpler than that. All right, so since we know we're starting with 1 mole is our given, so we're going to write this just like a stoic problem would be. And then we know that 1 mole of gas at STP has what volume?
22.4.
22.4, so we can put 22.4 liters on top and 1 mole on the bottom. Easy math.
Yeah.
So,
Okay.
now, do we want to solve that in the ideal gas law equation?
Well, I could.
We could,
It
but
does equal 22.4.
it will. So, if you want to do that just to see if we're right or not, go for it. But take our word. We're going to do the shorter step.
Yeah.
Okay? So, let's go on and try another one.
Yay.
So it said, what would be the volume of 8.2 moles of gas at STP?
All right. So when we have STP, I know that I can use my
Gas stoichiometry.
gas stoichiometry,
Now-
which is 1 mole is equal to 22.4 liters.
That is a key thing that Ms. Vaught said. It has to be at STP. If it's not at STP, we can't do the stoichiometry that way.
You'd have to use your PV equals an RT.
Yeah, but we like the simpler math if possible.
So if I have 8.2 moles and I want to know my volume, which is going to be in liters.
And I know that 1 mole is always equal to 22.4 liters at STP.
Then I can just multiply.
All right, so we multiply straight across. Again, if you don't have a calculator out, you might want to grab one. And we're going to do 8.2 times 22.4. And our answer is 183.68 liters, because moles cancel out.
And that's pretty easy.
That is pretty easy.
That's pretty easy. But again, you have to remember this, and you have to remember it only goes with STP.
Yes. All right, so take a stab at the 2 practice ones on your own.
Okay.
All right. Hello again.
Okay, so what would the volume of 0.4 moles of gas be at STP? Oh, yay, we're at STP again, so I can do my
0.4
4
moles.
moles in my lovely dimensional analysis way.
This is a lot quicker than using the ideal gas law. Now, does it work the same?
You'll still get the same answer doing the P
Okay.
equals NRT.
You will, but this is shorter.
This is shorter.
And I love
But
shortcuts.
again, it only works with STP. So it is something you have to remember to use when you see STP.
Right.
So it's kind of one of those like, if you can't make that correlation.
All right, so now, again, we've got to do 0.4 times 22.4, and our answer is 8.96 liters, because moles cancel out.
Liters, yep. Dink, dink.
Man, just when you thought you hated Stoic, I kind of like it.
Making everything easier. Alright. So, it's not as easy this time.
Okay, so it says use the equation. So we've got H2O decomposes to make hydrogen gas and oxygen gas. If there are 24 grams of water before the reaction, how many liters of oxygen should there be at the end of the reaction? Wow, so we have to go back
Man, we gotta use
to the stoichiometry.
Yeah, because this is liters, but I don't have to just change grams to moles to liters. I'm gonna have to change grams of water to moles of oxygen.
Okay, so maybe we should map out our math at the top just to kind of clarify this. So we're starting with grams of water.
Grams of water.
And we need to get to moles of oxygen.
Mm-hmm.
So we
Okay.
go to grams of
I gotta
water.
go to moles of water.
All right.
And then from there, I'm going to have to go to
Moles of
moles
O2.
of O2.
And then from moles of O2, then I could just use...
Then I can go to liters, right?
Okay.
Liters. Okay, I didn't bring that space there.
And we would have to make the assumption, even though it's not in the problem, since we're doing it this way, that it is at STP.
Right. Okay, so we would start, and you don't have to do a grams to grams, and then you're to liters. We can actually link it all together. There'll be one big track. Ooh.
All right, so
We're
we've got
gonna need it.
24 grams of H2O.
24 grams of H2O. And I know that if I look up my molar mass of water,
Good.
it is 18.
She's got it memorized.
memorized. And that is equal to 1 mole of H2O because my molar mass is always equal to 1 mole. And then I change my moles of H2O to moles of O2 using
Molar ratio, coefficients,
Yeah.
balanced equation. And in
Which
case
it gave us.
we're throwing out some vocab that's blowing your mind, coefficients are the big numbers in front that balance the equation.
2 for the H2O, and there's nothing there for waters or for oxygen, so what must it be?
A 1.
What? Yay! Okay, so I'm at moles. Do I need to go to grams?
Well, as long as we're trying to get liters of oxygen, so we have to get to moles of oxygen to get to the liters.
Mhm.
And we did get to moles of oxygen. So now we can use that nice 1 mole is equal to 22.4 liters.
So I don't have to go all the way to grams. I don't want grams, I want moles.
Okay.
So moles of O2 equals 22.4 liters. Okay, so 24 times 22.4.
Okay, so we're going to do this multiply across the top and then write our answer out.
Yeah, so they can see each time.
Okay, so across the top would be 537.6.
Okay, and then on the bottom is 18 times 2, which is 36.
So now I have to do 537.6 divided by 36 is equal to 14.93
liters, because cancel out, cancel out, cancel out, cancel out, cancel out, cancel out, leaving me with liters.
And more specifically, it would be liters of oxygen. All right, so give it a try. If you have questions, ask. Otherwise,